Hey everybody, going to start our conversation about experiments today. Another way of collecting data. So this is within Unit 3 of our AP Stats class. Now, we're not going to get into experiments quite just yet. We're going to talk about the other thing that we've already been talking about, which is an observational study. Observational study. So an observational study is when someone, researchers or something, observes data but does not try to influence the results. Not try to influence the results. Observes data, but does not try to influence the results. So some examples here, things that we've already talked about is like a sample survey where you send out a questionnaire and the respondents merely answer those questions. Ideally, you want to have it with the least bias or least amount of bias as possible. And that's really it. The researchers will observe that data, analyze that data, and then eventually try to make conclusions. Again, they're not trying to influence the results though. Another good example is observing wildlife. Like, I don't know, setting up cameras in the jungle to see how panthers migrate or something. I don't know, observing wildlife, another observational study. One other good example here is collecting dietary habits. So someone gets diagnosed with diabetes, they'll start to ask information. Well, what's your diet like on a daily basis? What led to you getting diabetes? That way they can eventually draw conclusions and try to figure out why people get diabetes. So collecting dietary habits for some condition, right? Again, that's all part of an observational study. So the observational study that I'm gonna kind of consider today and that we're gonna talk about is SAT prep courses. So it has been found that students that volunteer to take SAT prep courses, either after school or on Saturdays, typically have much higher scores than students that don't take these SAT prep courses. So for these SAT prep courses, volunteers have higher scores. People that are taking these SAT prep courses typically perform better. So the big question here is, should we just have everyone take this SAT prep course? Does the prep course cause higher SAT scores? So the answer to this question is probably not. Think about the people that are taking these SAT prep courses, the volunteers. They're taking time out of their day, either after school or on Saturdays, to attend these courses. So if they're volunteering to do this, they probably care very much about scoring well on the SAT. People that are not volunteering are probably not too concerned with doing well on the SAT, not so concerned with college admissions, and of course they're going to get lower scores because they just don't really have motivation to do well. Volunteers have a lot of motivation to do well. They really want to score well on the SAT to get some scholarships or get accepted into really good schools. So does the prep course cause higher SAT scores? Probably not. Probably not. Why not? So there's this situation, probably not. SAT prep course and scores on the SAT. This situation, it's known as confounded. Should be an O, confounded. So when something's confounded, we have a confounded situation. There's another variable that can explain why these students are getting higher SAT scores. So the confounded variable in this case could just be, I don't know, academic motivation. Maybe GPA would be a better predictor. Course load, what kind of classes are these students taking? Are they taking like pre-calculus and calculus, or are they going more like the applied math route? That could have another explanation of this response variable. So again, when two variables are confounded, there's probably another variable that can explain the response variable. So that's something that we need to talk about as well. A response variable, like another vocabulary word here. So we've done observational study. Now we need to talk about, we've done confounded, and now response variable. So what is a response variable? It measures the outcome, of a study or experiment. Response variable measures the outcome. The explanatory variable, it will help explain changes. It helps explain changes in the response variable. So in the example that I already provided, the explanatory variable was the SAT prep course. We were thinking that if students took the SAT prep course, it was going to cause a change in the response variable. Response variable here was the actual SAT score. By taking the course, we should see higher SAT scores. By not taking the course, we should see lower SAT scores, or at least that was the thought, right? Fantastic. Now, this is where our situation is at. We can't say that SAT prep courses prove or show a cause and effect relationship to the SAT score. The way around this, the way around confounded or confounding situations is experiments. Experiments is really how you get around this. So for an experiment, it's key idea. It's a lot like an observational study, but it has one key difference. An experiment happens when an individual, be it an animal, a student, a car, really anything that you're collecting data on, the individual receives a treatment. Individual receives a treatment. So like for an observational study, you're not trying to influence the results whatsoever. For an experiment, you deliberately try to influence results. In the case of the SAT prep course, a better way of doing it would be to assign some students to the SATs course, the volunteers that have already signed up, assign some students to take the SAT prep course, and then assign some students to not take the SAT prep course, and then, measure the response variable. That's really the idea behind experiments. A couple other things real quick regarding vocabulary of experiments. One thing is a placebo. So when you're comparing medical trials, like, does this medication work? Some of the individuals in that study are going to get the actual medical treatment, and then the others are going to get a false treatment. That false treatment is called a placebo. So a placebo is simply a false treatment. This helps the individual stay kind of confused. They don't know if they're actually getting the medication or if they're getting the false treatment, and it makes the results easier to compare. If the people knew that they were taking the medication, they might automatically start to feel better. If they knew that they were getting a placebo, maybe the effect wouldn't be so great. Lastly, in an experiment, the experimental units are those that get the treatment. Those that get the treatment are known as experimental units. I think of experimental units as being like lab rats, like they're always getting experimented on. When experimental units are people, if the experimental units are people, they're usually referred to as subjects. So just some terminology as we work through this experiments topic. For designing experiments, we'll wait until the next video. There's a lot of things to consider when you do that. We'll also talk about factors and levels and all kinds of other stuff. But anyways, the basics is observational studies don't try to influence the results. The issue with observational studies, since they're not trying to influence the results, is that your situation is probably going to be confounded by some other variable. Some other variable is explaining the change in the response variable. Explanatory response we've already talked about before in terms of regression. An experiment is when you do try to influence results, and you try to influence results by applying a treatment. If the treatment is like fake or doesn't have any active ingredients, it's known as a false treatment. And then experimental units are those that actually get the treatments. Lab rats or subjects for people or whatever. So hey guys, thanks for watching. That was just a very basic intro to experiments. See you in class. Bye-bye.